whether it's diabetes, hypertension, heart disease, all of those things are related to and tied to mitochondrial dysfunction and oxidative stress. As many of you know, the mitochondria is the powerhouse of the cell. It is where we produce ATP, which is the currency of energy for the cell. Imagine it's like an engine, okay? An engine, a regular internal combustion engine in your car. This is the part of the car that allows your car to drive. It gives power to the wheels, but it also creates heat. Heat is that oxidative stress. And if you don't deal with the heat that's coming from the engine with a cooling system, then you're going to have the engine shut down. And it's the same sort of thing that happens in the mitochondria. The mitochondria produces this energy, but in the process of doing it, it has to transfer electrons onto oxygen to make water. And if that doesn't happen in just the right way, you can make these oxygen radicals, things like superoxide, like hydroxy radicals, like hydrogen peroxide. These are things which the body can use to fight infections in certain ways, but it can also damage the mitochondria. And if that damages the mitochondria, that builds up oxidative stress, and that can damage the cell and leave you open to all sorts of these diseases. So what happens with COVID-19 is when the virus infects that cell, it knocks out ACE2. ACE2 is the receptor for SARS-CoV-2. We have all heard that. What we haven't maybe understood universally that we should is that ACE2 is a major enzyme in the regulation of oxidative stress. And so when that virus knocks out the ACE2, you now have turned the needle from wherever you were existing before. Let's say you were just sort of putting along. Let's say your engine was running a little hot, but it wasn't overheating. And now all of a sudden you get a SARS-CoV-2 infection. Now, instead of just getting along and your engine's running a little hot, you're now going up a hill. And now you're going to have an engine overheat. Your cell is going to shut down. And this is the issue that we have, not just with COVID-19, but also with just about any other viral infection that we can show. Now, here's the thing. Here's how this comes into and ties into what is it about sunlight that could be improving outcomes in COVID-19 that has nothing to do with vitamin D. As it turns out, and this is where we come to Scott Zimmerman and Russell Ryder's paper, who I know that you're going to have on your show at some point. That infrared light, which is a very specific component of sunlight, and we could talk about the characteristics of near infrared light. It's actually a very interesting discussion, but nevertheless, infrared light, and we haven't worked out exactly how this is doing it. We have some theories, but infrared light has a dramatic impact on the regulation of oxidative stress in cells specifically related to the mitochondria.
Wow. This is hugely important to understand, because my understanding is that just being outside, no matter what the season, no matter what the time of day, as long as the sun is out, there is infrared light present. And that infrared light, you're saying, is a critical ingredient to human health.
Yes, absolutely. So let's talk about the characteristics of infrared light. Over 53% of the photons coming from the sun, when I say photons, these are particles of packets of light. Over 53% of the photons coming from the sun on any given time, just on average, is in the infrared spectrum. A small percentage of the energy coming from the sun is in the visible spectrum, and even smaller amounts is in the ultraviolet. And so what I can say pretty safely is that the majority of the light coming from the sun is in the infrared. Now, have you ever pulled up to a stop sign and there's some people in another car next to you, and they're playing that really loud music? What do you hear in your car? You hear the boom, boom, right? You hear that low frequency sound. And why is that? That's because low frequency energy can penetrate through solid objects much more easily than than the higher frequency energy. So you're not hearing the high pitched sounds. You're not maybe hearing the voice or the melody. All you're hearing is the underlying boom, boom. That's the same way with sunlight. Imagine now the sun is giving off all sorts of frequencies of light, and then it comes to the atmosphere. So ultraviolet is a very high frequency energy. It's actually where most of the damaging rays of the sun are. It's in the ultraviolet section because there's a lot of ionizing radiation. The majority of ionizing radiation from the sun is in the ultraviolet area. We know that ultraviolet A is damaging to skin, but there's ways that the skin has of protecting against that. We'll talk about that. And then you have visible light, which is a little bit lower in energy, and that can come through fairly well. And then finally at the end, what we have is infrared light. So think about this. When the sun is very low in the sky, it has to penetrate through a much longer path to get to your body. It has to go through more atmosphere than when it's directly overhead at noontime, because it's directly penetrating through the atmosphere. It's a shorter distance. You understand this when you realize that when the sun is going down in the evening and at sunset, what typical colors are we seeing? It's the reds. It's the deep, right? And that's because it's harder for that higher frequency light like the blues to come through that. So the point is this, is that no matter where that sun is, whether it's low in the morning, right overhead, or setting in the evening, there is plenty of near infrared coming through that whole time, because near infrared has no problem passing through the atmosphere to get to your body. Now, it's not just that. It's not just that. Near infrared radiation has no problem penetrating through your clothes. Okay? So you're wearing 1 or 2 layers of cotton or polyester, whatever it is that you're wearing, or a combination. We actually have some studies that I was able to find that shows that 1 or 2 layers of clothing is not going to stop. So it has no problem penetrating through your clothes. Hold on, we got more. There's more.
That's so cool. Okay.
It has no
All right.
problem. It has no problem penetrating through your skin. Okay.
Right.
In fact, this paper, which I'll be referencing quite a bit today, is Scott Zimmerman and Russell Ryder's paper that was published in Melatonin Research back in, I want to say 2019.
Okay.
And he shows that, and this is mind-blowing stuff, what we're going to talk about here, is that your body is actually designed in a way to capture that infrared light and to spread it and diffuse it throughout your entire body so that it can be utilized by the mitochondria in your cells. So again, this is a completely different paradigm of what we're thinking about. Sun only affects skin. It doesn't, okay? To give you an example of how this is possible. First of all, I know that people are already listening to this and they're saying, how is it possible that light can penetrate through your body? So I had the privilege of meeting up and talking with, and actually having on our podcast, Bob Fosbury, who is a astroscientist.
Oh yeah, we listened to Bob.
Yeah. So
he's delightful.
You need to have Bob on your podcast.
Well, I would love to. I reached out to him. I haven't heard back.
Okay. So he sent me a picture of his hand with a near infrared, and it's out there. It's on my Twitter account. If you search, you'll see it. Bob Fosbury, and you type in @RogerScheult on Twitter, or on X, I guess they call it now. And he shows this light right behind his hand. And it's basically, the light just comes right through the hand. Now, you'd say, well, maybe I should be able to see the outline of bones.
Yeah.
This is mind-blowing. No, because the light goes right at that frequency of light. Bones do not stop that type of frequency. Okay.
Wow.
Okay. Okay. So this is, and Scott Zimmerman even shows this. Okay. This is even more mind-blowing, literally. Okay. Because this type of light, which very low frequency light. Okay. Again, think of the boom, boom. It's penetrating through metal. It's penetrating through we're talking about the sound now. You're at the car, you're at the stop sign. Think about what that speakers, those speakers are penetrating not only their car, but your car and shaking your steering wheel. Okay.
Right.
That's that type of low frequency sound. And what it can do is just amazing. Here we go. That type of light penetrates the skull. Okay. You've
Okay.
got a hat on. It'll penetrate the hat. It'll penetrate the skull. The first layer it encounters is the cerebral spinal fluid, which completely encirculates the brain. Okay.
Okay.
That diffuses it. So if light's coming on this side, that water, that cerebral spinal fluid, which is the same consistency as water, will diffuse that light all the way around the brain. Okay. And then if you've ever seen a brain, you'll notice that there are something called sulci and gyri. It looks like a walnut. Okay.
Mm-hmm.
There's ridges. So if you actually look at those ridges, and Scott Zimmerman, who is a light engineer who understands these things, says that the surface of the brain is engineered in the structure of the surface. We're not talking about the neurons, just the way it looks,
Mm-hmm.
is exactly the same way that engineers design airplanes to evade radar. And how it does it is that it does it in a way that whenever the light will hit it,
Mm-hmm.
it will be deflected to its interior to absorb that light. And so what you have are these valleys and troughs. When the light hits it, it goes down, disappears, is absorbed, and the area around the surface of the brain is the gray matter. What do I mean by gray matter? It's the area where the bodies of the neurons is on the outside of the brain, whereas the white matter, which is the myelin, which is the transmission, it's the cords, is in the center of the brain. And so where is mitochondria the richest? In the white matter or in the gray matter? It's in the gray matter. Okay? So in other words, what you have here is you have a solar system array. The brain is actually designed in a way that it maximizes the ability for infrared light to get to the second highest concentration of mitochondria in the body, which is in the gray matter of the brain. Actually, the highest concentration of mitochondria is in the eye. We'll talk about that hopefully in another point. But the point is that this infrared light is everywhere. It's outside. We have more to talk about there. But already we start to see the way that the body is designed is that it is designed to maximize that light's effect to get to the area that it's needed the most, which is the mitochondria.
This is incredible. Thank you for that excellent articulation. So, our brains are designed to absorb infrared light in order to maximize our mitochondria, which drives metabolic health.
Yeah, in the brain, all over the body. Glenn Jeffries, who's also works with Bob Fosbury at the University College London, has done some experiments, randomized control trials just published actually, that showed that light exposed to people, so in a randomized placebo-controlled fashion, that red light, infrared light, that spectrum again, reduced blood sugar and showed signs that basically it improved over a long period of time. It would improve diabetes. It's amazing stuff. There was a study that was done in Oxford, at Oxford and in Leiden. So Leiden is a city in the Netherlands, and of course Oxfordshire is in London. It's where Oxford University is, and they did a very simple experiment, but it showed a lot. They simply drew blood from a number of thousands of patients. Blood specifically looking at cholesterol, triglycerides, and also measuring insulin sensitivity. So these are all the things that are associated with metabolic health. And then what they did was they looked throughout the year, whenever these people had their blood drawn, they looked at the previous 7 days and went online and found the weather report and looked at how much sunlight there was in the previous 7 days. Okay. So, and they just correlated it. And what they found was that just within 7 days, okay, so this is not something that takes years for this to, just within 7 days, they found that the more light, the more sunlight, the more days of sunlight that there were in those 7 days, the better the cholesterol levels, the better the triglyceride levels, and the better the insulin sensitivity was in those patients.
This is so amazing because it really shatters our paradigm of how we think we need to manage our health, which is like purely through food and diet,
Oh, yeah.
and exercise, right? Like what you're saying is we can spike our blood sugar with bad light and we can lower it with good light. We can manage all of these different responses with light.
It's one, I call it the 8 pillars of health.
Yeah.
Sunlight is one of the 8 pillars of health. And what are the 8 pillars of health? It's actually really easy to remember it, because the mnemonic is new start. Okay, so
Nice.
N is nutrition, E is exercise, W is water. I'd be happy to talk to you about not only the internal effects of water, but also the external effects of water. So we're talking about hydrotherapy. These have very scientifically proven, shown effects on the human body. Start, so that's new. Let's go to start. S obviously stands for sunlight. So yes, this is one of the things that we're talking about today. But let's round out the rest of them. T, temperance. It's kind of an old term that we used to use for avoiding toxins in our body. So cigarettes, alcohol, things of that nature. A, air, fresh air. Cannot understate the effects on the human body to just fresh air. And it's not air that is devoid of substances other than oxygen and nitrogen, but it is air if you're going out into nature